Now we have to translate this formula to CNF, or closed normal form, or conjunctive normal form. For this, we definitely need to prenicize the formula, which means to move all the quantifiers in front. Fortunately, the very first quantifier is already in the prefix sum, so at the very beginning, we don't have to do anything with this quantifier. Of course, we do have to do something with the other two quantifiers, those ones. Since the scopes of those two quantifiers do not intersect, we can choose any of those two to start with. For whatever reason, I would like to start with the second one for all z, especially because it's really easy to leave this quantifier. We only need to move it in front, and that's it. So this is what I'm going to do. The result is exists y for all z. Then I start a huge parenthesis for all x, r, x, y implies r, y, x, and r, z, z. Okay. Now, of course, we should lift the other quantifier, but first we definitely need to eliminate this implication, because the quantifier is in the left hand on the left hand side of this implication. Anyway, let me eliminate this implication. I replace it with disjunction, and of course I negate the left hand side. This is still problematic because now the quantifier is negated. Before lifting the quantifier, we must move the negation behind the quantifier by applying the De Morgan laws. Therefore, this is exactly what I'm going to do. I flip the quantifier and negate the scope R, X, Y. Now we could leave the quantifier, but there is a problem because because variable x appears it has a free occurrence in the formula, in the rest of the formula. So we definitely need first to rename the bound variable. So let me rename this bound variable to v. And now we can leave the quantifier in front. So the resulting quantifier prefix now is exists y for all z, exists v. Okay, as you can see, now this formula is in prenex form because all the quantifiers are in front, and in their scope you can only find a quantifier-free formula. And now the next step, what is the next step? Well, first of all, we should recall the definition of a CNF, and especially the restriction about quantifiers. In CNF, only universal quantifiers are allowed. No existential quantifier should be inside such a formula. That is, we have to eliminate both existential quantifiers, and I hope you remember this process is called Coulomization. Let's start with the first quantifier. Since this quantifier is located at the very beginning of the formula, we can introduce a Coulomb constant and substitute it into the bound variable y. So let me call the constant c, and not only here, since y has another occurrence, but also there. And after that, I can remove the quantifier. Now let's remove the other existential quantifier, exists v. Since this quantifier is located behind the universal quantifier for all z, here we need to introduce a new function with the parameter z. And this is what I have to substitute into v. So I get fv here instead of v, and after that I can remove the quantifier. Okay, I think we are ready. I just erased the very important parenthesis. So the result is for all z, huge parenthesis, not r, fvc, or I forget a parenthesis here, or parenthesis starts rcx and rzz, and then a bunch of closing parentheses. Okay, what to do now? We are not ready yet, because this part, the scope of the quantifier, is not in CNF. It's actually in DNF, and you should know what to do in such a situation. We have to apply the law of distributivity, one of the laws of distributivity, and this is why we will get the following formula for all z, not r fvc or rcx. Actually, this is going to be the first clause, and not r fvc or rzz. This is going to be the second clause. So we have two clauses now. Let me just highlight them. They share the quantifier, and this is something we should change. We should, so to say, propagate the quantifier into all the clauses. Let me show you how this works. So basically, we put the quantifier in front of the first clause. So this is going to be the first clause with the quantifier, and we should copy the quantifier in front of the other clause as well. So this is going to be the second clause. Yeah, so long story short, after translating the formula to CNF, we get two clauses. Let me just take them. So here we have the two clauses, and this is the result. So these are the resulting two clauses. Okay, this is a solution to the original exercise, but I would like to show you something interesting, and I will try to do it as fast as possible. If you remember, at the beginning we chose between two quantifiers which one to lift first, and we chose for all z, if you remember. If this was not the case, then this would have been the quantifier prefix, what we would have got for all y, exists y, exists v, for all z. Exactly. And what I want to show you is that basically in this case, when we eliminate those quantifiers, then especially when we eliminate exists v, which is now in front of for all z, we could introduce another Skolem constant. Recall that C was a Skolem constant, and now instead of using f of v, I can use another Skolem constant like d. So I don't need a parameterized function, Skolem function, in order to eliminate this quantifier. And this basically makes everything more simple. And now I found some mistake, because everywhere I used f of v, but instead of, I should have used f of z. It doesn't matter, because we can remove this Skolem function and replace it with the Scholen constant d. So these are the two clauses we would get in this case. And also note that we can remove one of the quantifiers. We can remove this universal quantifier in the first clause because you cannot find z anywhere in the scope of the quantifier. This quantifier is completely unnecessary. So this is a very nice simplification. We get a totally quantifier-free clause in this case. Of course, the other clause is still quantified.